In the last few videos, we've looked at the sine and cosine graphs in a lot of detail, but something that we haven't looked at yet is the tan graph. So f of theta is equal to tan theta. This is one graph that we have not looked at yet. And this graph is actually very, very different to the sine and cosine graphs. You can recall from a few videos ago that we covered these sine and cosine graphs, that they look very similar to one another. And it turns out that the sine and cosine graphs are actually the same graph, just slightly out of phase. The tan graph, on the other hand, is a completely different graph, and we're going to look at that in some more detail today. Another thing that I just want to mention is I noticed in the last few videos I've been actually making a mistake in my terminology of f of x. So I've been referring to f of x and then writing down sine theta or cosine theta. And the issue with that is that I'm implying that the function is going to be with respect to x, but I'm putting it with respect to theta instead of x. So this should be written as f of theta is equal to tan theta or sine theta or cos theta. If I'm writing it as f of x, it should be in terms of x. So if I'm writing f of x, it should be sine of x or cosine of x. So this is correct, and this is correct, but this is wrong. So this is the wrong way to write things. You have to make sure that your variable is the same. So if I'm using theta as my variable in this case, it also has to be the variable in the brackets of f. So that's just a mistake that I had picked up while rewatching the videos, so please do make a note of that if you had looked at that from my previous videos and were a bit confused. But this is the right way that you should be doing things from now on. So without further ado, let's take a look at the tan graph in a lot more detail. So tan theta, as we know, is the opposite side over the adjacent side. And it turns out that this is the same thing as tan theta is equal to sine theta over cosine theta. And let me just prove that here for a second. So we know that sine theta is equal to the opposite side over the hypotenuse, and we know that cos theta is equal to the adjacent side over the hypotenuse. So if we had sine theta divided by cosine theta, we know that when we are dividing by something, it's the same thing as multiplying by the reciprocal. So sine theta divided by cos theta, sine theta divided by cos theta is going to be opposite over hypotenuse times hypotenuse over adjacent. And that's because here we have sine theta, opposite over hypotenuse. We're multiplying it by the reciprocal of cosine theta, which is hypotenuse over adjacent, because we know that multiplying by the reciprocal is the same thing as dividing by that thing. So now if we have opposite over hypotenuse multiplied by hypotenuse over adjacent, these hypotenuse are going to cancel out, and we're going to be left with opposite over adjacent. So sine theta over cos theta is equal to opposite over adjacent. And we know that opposite over adjacent is tan theta. So sine theta divided by cosine theta is equal to tan theta. So that is a very, very important trigonometric identity that you should remember. The same way that we remember that sine theta is opposite over hypotenuse and cosine is adjacent over hypotenuse and tan is opposite over adjacent, you should always remember that sine theta divided by cosine theta is equal to tan theta. And if we look at tan theta like this, tan theta as simply sine theta over cosine theta, we have a few things that we can already make note of about our tan graph just by knowing our sine theta and cosine theta values at certain special angles. We know that whenever sine theta is equal to 0, we're going to have tan theta equaling 0. That's because if we are having 0 divided by anything, it's going to equal 0. So whenever sine theta is 0, we're going to have tan theta equaling 0. And where does sine theta equal 0? Sine theta, as we know, is going to be 0 at 0 degrees, 180 degrees, and 360 degrees. So at 0 degrees, at 180 degrees, and at 360 degrees, we know that tan theta is going to be 0. Another important thing for us to note is that when cosine theta is equal to 0, and we saw that that was at 270 degrees and at 90 degrees, at those two angles, when cosine of theta was equal to 0, we're going to have an issue with tan theta there because we know that dividing by 0 is illegal in mathematics. We're going to get a math error. It is undefined. So we know that at 90 degrees and at 270 degrees, where cosine of theta is equal to 0, tan theta is going to be undefined. Tan theta is undefined at these points because that would mean dividing by 0, which is not allowed. And what's going to happen here at 90 degrees and 270 degrees is that we're going to have asymptotes. We are going to see asymptotes at 90 degrees and 270 degrees, and they're going to be vertical asymptotes. So already we can tell just by this information that our tan theta graph is going to be quite different to our sine and cosine graphs. We have asymptotes in the tan graph, which we didn't have with the sine and cosine graphs. And you can recall from the videos on hyperbolic and exponential functions that asymptotes are going to be these lines that our function is going to approach but never reach or cross. So already we can see that the tan function is turning out to be quite different than the sine and cosine functions. We have these two vertical asymptotes at 90 degrees and 270 degrees. And for now, we've seen only angles at which tan theta is equal to 0. But we're going to see in the next video that at 45-degree increments, unlike sine and cosine, which had our special angles at 90-degree increments, in the tan function at 45-degree increments, we're going to see our tan function taking on those characteristic values of either 0, 1, or -1. And we're going to see how that ties into the asymptotes and how that's going to lead to the characteristic shape of the tan function. So watch the next video to look at the tan function in a lot more detail.